Yeah, with extra cheese. And then throw in some, sorry, I gotta call you back. Oh, hello there. Welcome to Lombardi Labs. I'm Professor Lombardi, and I welcome you to join us for various scientific explorations and investigations. This time, however, we're gonna start, right from the start, the scientific method. All scientific investigations use a step-by-step means to test something or solve a problem. And we call this the scientific method. It all starts with an observation and/or problem. Look around you. What makes you wonder? Do you have any questions? This is where it all begins. Step 1, make an observation and/or notice a problem. Step 2, ask questions that are testable. Research if there's a way to put your questions to the test. If not, you need to go back to step 1. But if so, then you need to make a hypothesis.
Hypothesis, a prediction about the outcome of an experiment.
So step 3, make a hypothesis. It is an if-then statement. If I do this, then that will happen. Which leads me to step 4, plan and do your experiment. Make sure you work with an adult and be safe in whatever you do. Protect your eyes, hands, and anything else that needs protecting. Decide how you want to do your experiment. This is called a method. Then you're going to want to write down all of your steps. This is called a procedure. You will also need to collect data during and/or after the experiment.
Data, information from a test or experiment that is usually in numerical form.
Collecting and recording data is important for this next step. Step 5, analyze and display data. This is where you look closely at your data and interpret its meaning. What does it mean towards your original question? Then you want to find the best way to visually represent your data. Bar graph, pie chart, line graph, all 3. Analyzing and interpreting this data should help you arrive. Oh, okay, who is farting?
Oh, sorry. I think it's me.
We're recording here. What did you eat yesterday? Oh.
Just a bean and cheese burrito with some soda.
Seriously, you gotta cut it. I can't. Stop. Analyzing and interpreting this data should help you arrive to your conclusion. Step 6, report results in your conclusion. This is the most important part where you prove or disprove your hypothesis. What does it mean towards your original observation and/or problem? Any new questions? Let us now look at an example experiment using the scientific method, starting with an observation. I can think of one observation during this video. Some foods can make us gassy.
Sorry.
Really? We all know that beans make us gassy. There are even school songs about it.
Beans, beans, a beautiful fruit, the more you eat, the more you chew.
And this one.
Beans, beans, a good your heart, the more you eat, the more you fart.
With some research, you will even find that dairy products like milk and cheese can also make us gassy. And because of its carbon dioxide gas, fizzy drinks like soda can also cause gas. These observations can also be a stinky problem. So, what testable questions can we ask? Which foods and drinks tend to make me flatulate more?
Flatulate is the scientific verb for fart.
Believe it or not, this question is testable. And because it is, we can now make our hypothesis. If I eat enough foods known to cause gas, then my rate of flatulation will increase. Now it's time to plan and do the experiment. But first, we need to decide on a method followed by a procedure. We should first find out how much we are normally flatulating. And to do this, we need a control period. Decide when you'll have 3 days in a row where you can keep track of your gas. Make sure each day is a full 24 hours. During this time, do not eat beans, dairy, nor carbonated drinks. A good data sheet where you add numerical value will help break out the different types of flatulence. Single pop equals 1 point. Multiple pop under 1 second is 2 points. And long pop more than 1 second equals 3 points. The last column will be your total score. For 3 days, simply keep track of the number of times you pass gas, flatulate. Pay attention to the type and record it on your data sheet. At the end of the 3 days, find the average by adding up all the points and dividing by 3. Now it's time to test the effect of the 3 different food types over 3 days. Start each day with breakfast. Let's begin day 1 with carbonated drinks. You will need at least 12 ounces per meal. Since soda has high levels of sugar and you need to be drinking water anyway, I recommend sparkling water for this experiment. Record it in your data sheet the amount and kind of flatulence you produce. Give yourself 24 hours of normal diet between food trials to prevent overlap of high gas production. So 2 days later, eat half to a full cup of beans. It may be a lot, but you are doing it for science. Record this data onto your data sheet accurately. 2 days later, make sure you have dairy at every meal. At the end of the last 24 hours, add up the number of points, divide by 3, and compare to the average from the control period. All of this is our data. Now, analyze and display the data. What does it all mean? From this, you report your results in your conclusion. Perhaps you will notice that carbonated drinks produce the least gas, while dairy products cause the most. But all 3 gassy foods certainly produced more gas than the 3-day control period. Experiments often lead to new questions. It's okay if further research is needed to explain why some foods are gassier than others. For example, carbonated drinks will cause some carbon dioxide to be trapped in our gut instead of burped out. This will lead to... But don't worry, just because certain foods make us flatulate more doesn't mean it's bad for us. For example, beans are fantastic for our hearts and brains. They're even considered a superfood. You did it first. This was just one example showcasing the scientific method. There are thousands of other experiments you can do safely at home. Just remember, it all starts with an observation and/or problem.
So it's okay for me to fart freely now?
No, sorry.
Oh no! Oh!
Until next time.